Next, we're going to talk about how to simplify radicals. So these are the 3 steps you take. You're going to create a factor tree for the radicand, create groups based on the index, box everything that's left over, where circles represent perfect squares and cubes, and then finally you're going to take one representative from the circle groups, and that goes on the outside. Everything boxed stays on the inside. Right now that probably doesn't make a lot of sense, but hopefully if you read that after the lesson, it will make more sense. So step 1 is to create a factor tree. What a factor tree is it looks like this. We're going to take that radicand and we're just going to break it down into some of its factors. The nice thing about factor trees is it doesn't matter what factors that you choose because you'll always end at the same result. So 117, some factors of that are 3 and 39. If you don't know the factors of a number, just use a calculator and just divide by random numbers until you find something that works nicely. And kind of the goal here is to get to a prime number. So 39 can be broken down even further into 3 and 13. And then 13 and 3 are both prime, so we can stop there. The next thing we're going to do is we're going to look at the index. And since we don't have an index written, we know it's 2. So looking at our factors, we are going to look for groups of 2 things. Looks like we've got 2 3s here. And then we only have 1 13, so that would be considered a leftover, and we're going to box it in. And just note that we're only concerned with ends of branches, so we're not going to do anything with that 39. Now, if we rewrite this, what we do is looking at the group of 2, 1 thing in the group of 2 goes on the outside, and anything left over stays on the inside. So the 3 goes on the outside, and the 13 goes on the inside. Now, just to help you see what the heck we're doing when we're circling things, I'm going to multiply the 3 and the 3 together, so we can rewrite 117, the square root of 117, as 9 times 13, which would be the square root of 9 times 13. And we can actually break those apart and have it mean the same thing, so this would be the square root of 9 times the square root of 13. Well, what is the square root of 9? That's just 3. So, and that just so happens to be the exact same thing that we got there. So essentially what we're doing when we're circling groups is we're just looking for the perfect squares. So we're just looking for the factors that are perfect squares that can be simplified into a number, and that's what the groups represent, is they represent the things that are perfect squares. Alright, number 2, let's do another example. So factors of 320, let's start with 10 and 32. 10 is 2 and 5, 32 is 4 and 8, 4 is 2 and 2, 8 is 4 and 2, 4 is 2 and 2. Okay, so our index there is 2, so we're going to just go ahead and circle groups of 2 things. So we've got 2 2s there, 2 2s there, and then we've got a 5 left over and a 2 left over. Okay, so we'll start with the 4 that's on the outside, because if it's already on the outside, it's going to stay on the outside. So that will be the 4, and then just like before, we're going to pull out anything that was a group of 2. So we've got one group of 2, and then another group of 2. And that's everything, and then left over is 2 and 5. You know what? I just noticed I'm missing a 2. Apologize. There's another 2 right there on an end of a branch that I missed. So we're going to need to multiply by another 2. We've actually got 3 groups of 2 and a 5 left over. So everything that gets pulled out, it gets multiplied. And just so if you need to see, that group of 2's became that 2, that group of 2's became that 2, that group of 2's became that 2, and this 5 became that guy. Maybe that helps you see where those all come from. 4 times 2 is 8, times 2 is 16, times 2 is 32. So this simplifies to be 32 square root of 5. Okay, another one. So let's break down 48 into its factors. 48 is 4 times 12. 4 is 2 times 2. 12 is 3 times 4. 4 is 2 times 2. Go ahead and circle the pairs. Ooh, just kidding. What's our index? Our index is 3 this time. So we're actually circling groups of 3. So we've got 3 2's, and then we've got a leftover 3 and a leftover 2. So if we pull those out, we've got the 2 out front that's got to come along for the ride. Pull out 1, 2 as a representative for the group, and then rewrite our radical. Make sure you remember the index, and then everything inside gets multiplied. So 2 times 2 is 4. Cube root of 3 times 2 is 6. Next one, let's break down 108. That is 9 times 12. 9 is 3 times 3. 12 is 3 times 4. 4 is 2 times 2. Our index is 3, so we're looking for groups of 3 things. Got 3 things there, and then 2's left over. All right, so we've got the 3 outside that's got to stay outside. We've got the 3 from our group of 3's. Everything else has to stay inside, so we'll have the cube root, and then we have 2. 2's left over, so those get multiplied. 3 times 3 is 9. 2 times 2 is 4, so that simplifies to 9 cube root of 4. Next one, so this is interesting because we've now introduced a negative, which you can actually take the cube root of a negative number, because for example, if we did negative 2 cubed, that's going to be negative 2 times negative 2 times negative 2. 2 times negative 2 is 4, times negative 2 is 8, is negative 8, so the cube root of negative 8 we just saw is actually negative 2. So you can take the cube root of a negative number. What you need to know when simplifying a cube root that has a negative in it, you can go ahead and turn the negative into a positive and move the negative outside like it's a negative 1. Then, when you break down the radicand, you're going to do the same thing we were doing before, factor trees. 250 is 25 and 10. 25 is 5 and 5. 10 is 5 and 2. Our index is 3, so we're looking for groups of 3 with 1 left over. So if we rewrite this, we're going to have that negative 1 that was out front, that we moved out front, that's going to come along. There's a group of 3 5, so one of those can come out, and then left over in the root is 2. Negative 1 times 5 is negative 5. So that will be negative 5 cube root of 2. The next one, we've got that negative on the inside, so we can go ahead and move that to the outside. 2 is a prime number though, so it's not going to have a factor tree. So that's actually as far as we can go. That one simplifies to negative 6 cube root of 2. All right. I want you to go ahead and pause the video and try number 7 and number 8. Number 8 is a pretty big number, but remember, just type it in your calculator and find some good factors and then break it down. All right, number 7 simplifies to be 9 fourth root of 2. Number 8 simplifies to be 34th root of 2. If you have any questions about those, please feel free to come talk to me. The last idea that I want to introduce in this video is radicals with variables. And so when we're dealing with roots, if it's a cube root, our exponents need to be a multiple of 2 in order for them to be simplified all the way. Our cube roots need to be a multiple of 3, and our fourth roots need to be a multiple of 4. So you'll kind of see what that means here in a second. So the way that you do this, you'll start by breaking down the number into its factors. So 32 is 4 and 8, 4 is 2 and 2, 8 is 4 and 2, 4 is 2 and 2. Our index is a 2, so we're looking for groups of 2 things. And then we have 1 left over. So rewriting just the number part, we have 2 times 2, since we have 1 from each group. And then looking at the variables, well, that x to the 4th, there's kind of 2 ways that you can think about this. The first way is, how many x's do I have? Well, I have 4 of them, and we're looking for groups of 2 things. So how many groups of 2 do I have in 4? Well, there's 2 groups, so that means I can pull out 2 x's, which will be x squared. Another way to think about this is if we kind of look at a factor tree like we've been dealing with, we can break that down into 4 different x's, and then we're looking for groups of 2 things. Well, we have 2 things, so that would mean that we're going to pull out an x times an x, which is just x squared. Okay, with those y's, we have 9 of them. How many groups of 2 is in 9? Well, that's 4. And again, if we kind of use our factor tree idea, I'm going to break these down into y squared groups, since we're looking for groups of 2. So that's 2, 4, 6, 8, and 9. So we've got 1, 2, 3, 4 groups of 2 with 1 left over. So that's where the 4 comes from. And then inside, we had a 2 that needs to remain inside, and then there was 1 y left over. Simplifying that, we get 4x squared y to the 4th square root 2y. Number 10, 324. I'm going to start with the factors 12 and 27. You could use whatever factors you wanted, and you'd get to the same place. 12 breaks down into 3 and 4. 4 is 2 and 2. 27 is 3 and 9. 9 is 3 and 3. My index is a 2, so looking for groups of 2 would be both of those. Oh, and we've got 2 more right there. So looks like everything got circled, which means that everything can be pulled out. So that will be, we've got a group of 3s, another group of 3s, another group of 2s. Then I'm going to do my variables. So I have 3 A's and I'm looking for groups of 2. There's 1 group of 2, so it'll be 1A. And then I have 7 B's looking for groups of 2. That would be 3 groups of 2. And then inside my radical, I have no numbers left over, but I do have 1A and 1B. 3 times 3 is 9, and then times 2 is 18. And then AB cubed, square root of AB. Number 11, 216. I'll choose 8 and 27. 27 is 3 and 9. 8 is 4 and 2. 4 is 2 and 2. 9 is 3 and 3. Looking for groups of 3 things. That's a group of 3 things. That's a group of 3 things. So it looks like that one's going to be able to simplify nice as well. That will become 2 times 3. And then looking at the m's, there's 3 of them, which is one group, so I'll just pull out one m. And then the n's, there's 6, which is 2 groups of 3. And it looks like there's nothing left over. No numbers, no m's, and no n's. So that's actually the end. We don't need to write anything inside of the radical. And that just means that you can actually take the cube root of that number and not be left over. There's nothing left over. Okay, number 12. Same thing. We're going to break down 56, which is going to be 7 and 8. 8 is 4 and 2. 4 is 2 and 2. Our index is 3, looking for groups of 2 things. So we're going to be able to pull out a 2. And then looking at the r's, we're looking for groups of 3 things. And we have 8. So that's 2 groups of 3 with 2 left over. So maybe I'll even write that as I'm going. 2 left over. Oh, just kidding. I'm not going to do that. With 2 left over. And then S, how many groups of 3? Well, 1 group of 3 with 1 left over. So then if I draw my radical, everything left over goes inside. So looks like I had a 7 left over. 2 R's and 1 S. So that would be that in simplified form. Next one is negative 64. Well, we're going to go ahead and move that negative on the outside. And then do the factor tree for 64, which is 8 and 8. 4 and 2. 2 and 2. The index is 3, so we're looking for groups of 3 things. Looks like that one's gonna simplify nice as far as the numbers go. So we'll bring that negative 1 from earlier. 1, 2 for the first group, another 2 for the second. Then we have 10 x's, and that would be 3 groups of 3. So we'd have x cubed with 1 left over. Y21, that's 7 y's. And then our radical, don't forget the index. There's no numbers left over. We had 1 x left over and no y's. So simplifying that is going to be negative 4x cubed y to the 7 cube root of x. 14. Again, we'll go ahead and put that negative 1 out front. 81 is 9 and 9, which is 3 and 3. Our index is 3, so we're looking for groups of 3 things. We have a leftover 3. So the negative 1 comes along, we pull out a 3 for the group. P squared, there's 2 of those and we're looking for 3, so no p's come out. Q to the 12 means how many groups of 3 would that be? Well, that's 4. And then left over inside of our radical, we had 1, 3, both p's, and no q's. That's going to be negative 3 q to the 4 cube root of 3p squared. And this is where you shine. This is your opportunity to do number 15 and 16. Thank you for pausing the video. So if we do this, we've got 4 W's and we're looking for groups of 4, so that'll come out. We've got 17 W's, which means there's 4 groups. That gets us to 16, so v to the 4th, and then we'll have 1v left over. That one was nice, didn't have to do the factor tree. And then this one here, we've got 4 and 12. 4 times 4 is 2 and 2. 12 is 3 and 4. 4 is 2 and 2. Our index is 4, so we're looking for groups of 4 things. The 3 left over. So we can pull out 1, 2. M to the 8 is 2 groups of 4. N cubed is no groups of 4. So then we'll write our radical. Don't forget your index. We had a 3 left over, no m's left over, and all 3 n's left over.